So, hi guys. Yeah, welcome to the third day of this Rhino course. Welcome on. Yeah, so let's start with it. So today we'll understand curves within rhinos, mostly 2D things like planar things, how how we can work with 2D objects, that's line, curves, polylines, and many more. That I'll discuss with you. And I'll show it to you here on Rhino. And share my screen. And before that, what we'll do, I'll yeah, I'll talk about all those things that we discussed last time about during the introduction of Rhino once again, so that everyone gets freshened up on that. So yeah, let's start with it. Over here at the top, we have the menu bar, the history bar, um, through which we can see what all. Okay, yeah. From here, we can see what all changes we have made, what all commands we have used, and what's the process that we have gone through. In the command line, whenever we write a command, it shows us. And then the standard bar on the side, we have the sidebar. We can just scroll it over here to change the tabs. The four viewports, by double clicking on it, we can go into it, and doing the same, we can move out. And yeah, the four viewports, top, front, right, perspective. I'll make a geometry so that like this. In the top, it looks like this. I'll change the view style, one for the shaded, other for the rendered. And we'll go with ghost day one. And in the front, we'll try for X-ray. These are all like the styles. I haven't talked last time, but styles are important because while doing complicated models, styles helps us. Even for presentation purpose, we can say in ray trace, right now I don't have any material over here, but material looks correct, and also the lights and shadows, it works here. And yeah, you can try with styles. So this was about the viewports. Over here, we have the panels. I suggested to use properties while working so that we can see the object is closed or not over here. Also working with layers and yes, display. Even this is important. So let's start with it. Curves within Rhino. So before understanding curves, there are other aspects as well. I mean, not aspects, but I'll say elements, such as lines and polylines. I'll draw out the tabs first. So I'll cascade it down. So that's the line. We'll go with points also. So we have lines and polylines over here. We have points. Then under the curves, we have free-form curves within Rhino. We have under lines, we have circles. That's polygon. Rectangles and they are polygons. And these are curves. We have conical objects over here. Just a second, guys. Yeah. So I'll repeat once again what all we have under curves and lines. So first we have lines and polylines under this tab, which I've dropped down from here. I've dragged it under the line section. Then we have free-form curves, which is over here. These are the free-form curves. We have conic curves as well, which are here. I'll explain in detail everything. I'll try each and every icon over here. And also under lines, we have circles, rectangles, and polygons. So, and yeah, about helix and spirals as well. So let's start with it. So we'll go into the top view. We go back to our geometry class that we did in 10th and 12th. So starting with that, a line is a segment made from 2 points. So line is a segment with two ends. Segments has two ends. And then so these are the 2 points that I am drawing. And then from line, single end, start and end. And this is how we get a line. So it's not necessary. I was just explaining the process, what the geometry consists of, what the curves or what the element line is. Yeah. So points helps in various ways. For example, when I make a solid, I go into the perspective. Yeah. When I select, even solids has its own constituent properties. For example, when I use Control and Shift and drag it over here, I get a vertex. And then when I stretch it and pull it, the object deforms. Okay. Yeah. I'll do a click on the surface edges so that it's quite visible. Other properties of solids are its edges. Again, Control Shift, I click it over here, then with the help of gumball, I drag it like this. And then others are surfaces. Control Shift, click, then this is how it updates itself. So this was about solids. The same happens in curves, lines and curves. So yeah. So I'll try each and every one out. So it says single line. It's just a segment. So when I do first click, it says end of the line over here. You can see at the command bar, and then click it. Then the line is then the command terminates. The command is finished. But when I use the polyline, I say start. It says start of the polyline. It's always good to, whenever we are using any command, it's always good to have a look over here at the command bar and read what it says. It says start of the polyline. I click it, that's it start. It says next point of polyline. Then I'll click it here. It says next. The command is polyline. That's why I can use many lines at the same time. That's why I wrote polyline. And then I can use that same thing in front view. And then plane Z axis. But that's the same polyline. It's difficult to visualize. I'll change the ground plane. See, make surface. Yeah, we can see. So these portion of the lines were drawn in top view, and these in the front. They are not in same plane, but it's drawn in XY plane and XZ plane, which was over here from the front. Yeah, XZ. So this was polyline. We can also have normal to the surface. For example, when making a surface, we'll talk about like making surface and all. It's in tomorrow's session. But yeah, in order to know how the lines works and what are its applications, I'll just show it to you. I'll show this once again tomorrow as well. Yeah, so that's an undulating surface. It says normal to a surface, and it draws a normal. So in some, like there may be some requirements to establish a point of contact over here to place an object on an undulating surface. For example, while working on a topography and you have to establish some points and all, then this helps, this command works. Like this, and it's fun. Spooky also. Okay, so this was about it. Vertical to C plane, point, line from 4 points. Yeah, line through points. For example, when I'm having multiple points, I want to establish line which is like going not through it, but passing in between, like an average line. Then this command works, like line through point. Do it once again. Yep. And also for selection, whenever we are selecting an object, we can click on it, or we can do drag it behind or drag it front. In AutoCAD, dragging behind and dragging front is different, but in Rhino, it's the same. And in order to deselect it, press Control and then click. In order to select multiple, press Shift and then click all the objects, like here, like this. And then to deselect it or remove from that selection, press Control and drag. So drag your cursor around it, then it will deselect. Yeah. So this was most about lines and polylines. It's a segment. It's curves and lines are different. So we'll go with next on circles. There are also various types, like even to draw a single circle, but using different conditions. For example, starting with radius, center of the circle, let's say here, and then we can give a diameter. I can type it in. You can see I can over here at the command line when I'm inputting the dimensions, it's 1500 right now. I can see like whether that ratio is proper or not. It gives an instant preview like this. So next is I'll say 155. It becomes bigger. So the preview is instant while running, but right now it's not made. We have to click it somewhere outside the screen, like this. We press space bar to enter or reactivate the same command. So now space bar, then I'll say that's the point of center, and then I can do it with my mouse or press 125 number. But if I press escape, then like this, I can go back to the original one. And then once again, when I press escape, command is gone. That's why it's important whenever we are working with any commands or once the command is done, even though we see here is a preview. We see the preview and then we have to press enter or press somewhere else outside. So this was about working with commands. Circle from a diameter like this. So now my snapping is at the center over here. When we come in the snap bar, which is here, my center is ticked. When I untick it, it won't snap to the center. But when I say at the tangent to a circle, it should snap. See, it's not. I'll come back on this again. Adding snapping to a tangent. Yeah. So now it's snapping at. You can see what the snap points are. It's a knot and it's an end. And it says here is the tangent, but yeah, so that's the tangent to the diameter. So when I'm drawing a line from here, where is the intersection? Yeah, here's the intersection. Yeah. So the command that I had used was circle through a diameter, and as we can see, the first point was at the edge of the circle, and the next was where the tangent forms. So uh, that's why it wasn't showing. But when we will say, let's try with this one. It's again going the same plane where it snaps. This is at the core. Yeah, tangent. Snap at the center. So what happens whenever we are not getting the center? What we can do, we can come at the circumference of the circle, and then until this gray point is popped up, then we can select. Once again, I'll do it. I'll come at the circumference, but it's this center point is not activated till now. Yeah, see, it turned gray. and then I can snap it, and then the tangent to this circle, the line is tangent to this circle. Then yeah, circle tangents to three curves. Okay, let's try this one. I'll delete it. I'll move tangent first curve here, and tangent stop, and yeah, no, this one. Let's try once again. Three curves. So that's the tangent here, and then here. Yeah, that's it. So reason I'm going into such detail like how to snap curves also, because later on when we are extruding any geometry from curves, there is no error in it. Like your geometry is like proper, and there are no issues with it, and it helps later on in later stages, even while extracting drawings and all, and also for renders, there are no gaps, nothing. That's why we are going into such precision. And the good thing is that Rhino can do such things. So why not try that? So it was about circles and then rectangles, rectangles from center. You can snap it, and also polygons. So it says number of sides. So what I'll do first, I'll mark the center, and then number of sides maybe, let's say three. Three is the smallest number, like the least, because a polygon has minimum of three sides. You can go to like more like five sides, hexagon, or say from 10 sides or 100 sides. No, no, that wasn't side. Number of sides, and then 100. Yeah, that's a polygon with 100 sizes. It's a facet we can see over here. When let's try exploding it, should give me a, yeah, it gives us a segment. So a polygon. And then coming to curves, finally to curves. This is an interesting one. I'll switch the layer now. Double click, we enter the layer. Yeah. So curves within Rhino, like these curves, are called as NURBS curves. Like last time we had talked about NURBS, non-uniform rationally based spline. Finally. So what this does, it gives us accurate drawing, like what we are drawing. Like one of the reasons Rhino has an advantage over the softwares is because of such commands. Like it can work very easily and smoothly with curves, and also we have really good control over curves. Yeah, and the difference between curve and a line or polyline is the degree and the control points. So what is a degree? So you can see over here, it says degree. When the degree is 1, we can't see any deviation in the curve. Like even though it's in the same line right now, I'll switch it on the and move up. See, because of degree 1, it's not taking any shape of the curve. I've used the same command here, which says control point curve. I'll use the same thing once again. I'll say now the degree is 3, and when I'm using the same line, see, now because of the degree, the curve over here has taken a deviation. It's taking a curved shape, whereas both of these are from the same command. But because over here we have degree 1 and here we have degree 3, that's why it's over here. Minimum of degree 2 can give us a deflection in the curve. Let's try with that. So now I'm working with control point curve. So it's a name of the curve. Now let's see, try with degree 2, and we can see the deviation. The deviation is less right now. No, sorry, the deviation is more, but as and how we increase the degree, the deviation gets less. degree of 5 or 10. Yeah, it's lesser as compared to degree 2, you can see. And that was about the control point curve. And also, what is control point and interpolate point? Both of these are really useful to make curves. For example, if we are tracing some curvilinear object, then in AutoCAD we used to work with splines and then convert its edit point into fit points and then make and then draw it across the reference plane. But over here, when we use interpolate point, you can see the degree is 1, that's the degree is 2. Now I have exact control. I can see where the next curve I have to bend in order to get smooth transition within the curve. But while using over here the control point curve, see over here, the both of these curves are governed by two different sets. Yeah. So we have points with on the curves which control the curves, like you can see, and now it has turned into control point. And over here we had used control point. Yeah, interpolate, so that's the interpolate curve over here, and that's the curve through control points. And that's one thing. We can draw on surfaces because the reason is there is little bit of flexibility on other softwares uh, while jumping from 2D to 3D, but over here it's really great. So I've selected the surface. It asks me to select the surface to draw curve on and select the surface. That's the undulating surface that we made previously, this one. And let's go to the top view. I'll draw on it. I don't need to snap it. I'm just drawing it randomly. Let's see how it comes. And also it's important to close the curve. For example, when my snaps are off, and even though I say that I'll click it here and it will snap and my curve will get closed, but it won't. It's always good to close it from here or press the initial C. And yeah, the curve is closed. We can see that's the geometry that we have achieved over here. For example, that's the shape that I want to take out from this topography. I'll trim it. That's the cutting object. Uh, that's the cutting object, and then object to get trimmed here. So it was like easy to develop a surface, make a larger surface, and then with help of curve, draw on the curve or any surface or even on mesh. It says sketch on polygon mesh and then extract from it. And there was one more fun thing that I was looking today. It was sketch through polylines or lines. I'll search sketch. Yeah, this is an interesting one. It's click and drag. You just need to drag it. Like for example, even though we are tracing or showing it to someone, you can drag it in any plane we want. Let the snap be on. And when I press enter, oops, no, in order to finish it, yeah. So here I made a mistake. In order to finish the command, and instead of spacebar, I had to press enter. I didn't. So let's do it once again. Just making some wavy pattern. So top view, let's do it. The right view as well. Then, yeah. So that's the curve that we have achieved. It's funny. Let's have some more fun. Let's go with pipe. Let's, we'll discuss everything in detail, like pipes and surface. No, this was just for some fun. Yeah, see, some interesting form. Created. And also there are, so these were curves. Okay. So these were curves over here, NURBS curves. We have conical curves as well. So for example, what are conical curves? So the curves that are extracted from cone that can be easily achieved here. When I make a cone and slice it, how did you give thickness to the curve? Yeah. So there's this command called as pipe, and with help of pipe we can give thickness to the curve. It's not thickness, but it's another geometry which is modeled on that. Yeah. 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 So I was talking about conical curves. When we have a cone and then when we trim it, so the curve that we get from here, from the cone that is sliced, is the extract curve. Is ice. But we don't want. Yeah, we can go with iso curves also. Yeah. So the geometry that I extracted, that's from the cone, but it's easily, even though it's a circle, but when we slice it in another direction, like this,
How did you slice it?
with help of trim.
Okay.
Yeah. So with the help of gumball, I've rotated it in any plane I want from the front view, and then it's always good to slice any geometry with from curve to the targeting object from front view or right view or left view, but not from the top. If you're slicing in top, then it's fine, but in perspective, trim and slice doesn't work. So I'll go with trim as the cutting object, the target object, and yeah, here we have a slice. So all these shapes and all we can achieve from conical curves here, parabola, hyperbola, and all. And also catenary curves and helix. Let's try with helix. So helix, it has an axis around which the curve rotates uniformly or non-uniformly. So here's the helix. While in spiral, we can have 3D spiral or flat spiral. You go into the top view. So that's the helix that we have made. So we'll say we'll go for a flat, flat spiral. We'll have a center and then the rest, uh, the curves that are going outside in an increasing fashion.
रक्षाबंधन हा वक्त थोड़ी रक्षाबंधन
Yes. All right.
बाई ये शायद ती घड़ी कहीं नाखी है
Guys, can you mute it, please?
कीवर म्यूट कर
I'm unable to get the command to mute or. Yeah, that's done. There's one more. Can you control the degree you turn with gumball? Can you control the degree you turn with gumball? Yeah, that's a good question. So over here, I have degree or the control points to be specific.
I mean, can you put some, like you want to move it by so much or so much when you're doing it with parameter? I mean,
Okay, okay, rotate it, right?
yeah, like,
Move it. Yes, Smriti.
As in, like, if you wanna with the gumball move it by like 5 or 10
Yes.
unit, then can you do that?
Yeah, sure. So that's the rotation command over here. So in planar modes, that is top, front, right, and left, we can see that's the rotation arc. In 3D, we can see all three of them. You click on any of it, and then that's the direction, the arrow which is going, and then we press any angle we want. It's always in degrees. Yeah, so this is how we can do it. So rotate it at particular angle in which axis we want. Same goes for scale. If I want to scale it by say 10% or by increase it by 10%, then it's gonna do it in single plane. Right now I have given the scale command in one direction, which was in blue one, which was Z direction. So I've clicked on it, I've given by 10% and then got scale like this. And also for the move, the gumball is really helpful for scale, rotation, and move. For move, you can type 50, then it will shift. Right now, the increment was really small, and the distance was really small. Let's go for 5,000, and yeah, it got shifted like this. Also, while dragging, we can drag it, press Alt, and make a copy of it. We can see the plus mark on the icon on the cursor. That way, we can do make a copy, and then with the help of delete it. Yeah. So where was I? So at the flat spiral, have a spiral center, give a radius, minimum radius, and then what should be the distance between the spiral, the say, second radius, which is that how the spiral will form, and that's it. So I'll say this was all about curves for today, understanding how it will go. The interactions of curves, there are, I'll say trim, join, explode, all are similar as what we have in other softwares. For example, I'll do it here. If I want to trim, I'll press trim. I'll select all as the cutting object and then enter spacebar, hit spacebar, and then select what I want to trim it. So because our geometry was so precise that trimming and joining would be easy. So that was trim. I'll select once again everything. I'll hit join, J enter. So here are the commands. We can say join, we can explode it, trim, untrim, split, and also make groups and all. See? Yeah. So here's join. And one more thing. In Rhino 6, the cool thing that they have done is when we select any geometry, say for example curves, surfaces, or solids, it highlights the control points. And so we don't need to go over here in order to activate. In Rhino 5, we always have to go over here and say show object control points or say show curve edit points. But here in Rhino 6, it's easy. Just select the object and then if I want to stretch it up, I can do it. Yeah, see? It's quite easy. The same goes for surface that I'll introduce to you tomorrow. And that's it, guys.